So this is day 2 of our last month crash course. Let us get into the first problem. Please solve the problem on your own. Then you can look for the solution. So let me now start the solution. So in this particular problem, let us see what we are given. We are given that the block will finally completely get submerged into the liquid, right? Fluid. And therefore, let us consider the diagram at the final state. In the final state, this is how the block will look like. Let us consider the initial free surface level to be a reference level A. So here also we can draw that reference level as A. And initially block was on par with A, but the block has gone down. So let the block go down by X to get completely submerged. During this time, the fluid also goes up, and that is the reason why the block gets submerged without going down by its full height H. If you take the side of the cube to be H, we realize that the block need not really go down by H to get completely submerged. Okay, now we realize that if the block has gone down by X from the initial datum level, that is the initial free surface level A, then all this X, depth of the fluid, all this fluid of this much volume that is, there here, has gone to the sides. Now, let the surface area of the cube, the cross-sectional area of the cube, let it be S, then that of the container, which is 3 times that, will be 3S. So here, the volume of the fluid is 3Sx. Now, that has occupied this much volume over here, which is 2S into H. Why? Because the cube area is S and total area of the container is 3S. So the remaining area of cross section, that is 2S, is occupied by the fluid. So the volume of 3Sx finally has occupied 2SH. So X comes out to be equal to 2H by 3. And now we want work done by gravity on the block. Block has gone down by 2H by 3 distance, and therefore work done by gravity on the block is nothing but mg into 2H by 3. mg into 2H by 3. This is work done by gravity on the block. Now, work done by spring on the block is being asked. Now, for that, we need to understand that the upper end of the spring is being lowered and the block is also moving. So both ends of the spring are moving, and therefore the work done by spring in total is work done on the ceiling as well as work done on the block, because both ends of the spring are moving. And that is why work done by spring on the block cannot be equated to negative change of potential energy of the spring, because the minus delta PE of the spring equals to total work done by spring. But we need work done by the spring on the block alone. And that is the complexity in this particular problem. Now, let us try to understand, about the fluid which has been displaced or which has come to the sides. So this 3Sx or 2SH volume of the fluid originally had its center of mass at a height of x by 2, okay, from this level, which I will call it as some P. Now the same level P is somewhere here, and its center of mass is at height h by 2, okay, from P finally. So a volume of the liquid which is 2SH volume of liquid okay has delta y center of mass. That means the displacement of its center of mass to be h minus x by 2. So x is 2h by 3, so this comes out to be h by 6. So work done by gravity on the liquid is equal to, its volume is 2SH into G, but it has gone up. So the gravity acts downwards, but it has gone up. So into minus h by 6 is the work done by gravity on the liquid. Since I have forgotten the density of the liquid. Okay. So 2 times density of liquid is density of the solid, because specific gravity is 2. And that's why this can be written as density of the solid into S, which is the area of cross section of the solid also, into H into G into minus h by 6. So you can realize that this is nothing but mg for the solid. Okay. So work done by the gravity on the liquid comes out to be minus mg h by 6. Okay. So work done by the other force, okay, work done by block on liquid, because the liquid pushes the block upwards through buoyancy. So the block will push the liquid, okay, as well. And that's why the liquid, okay, will do some work on the block, and block will do the same amount of work on the liquid. So we are calculating work done by block on the liquid, okay, which should be mgh by 6. Because total work done on the liquid shall be 0, because its kinetic energy has not changed. So work done by liquid on the block will be negative of this, so minus mgh by 6. So now for the block we shall write work energy theorem. Work done by the spring on the block plus work done by gravity on the block plus work done by liquid on the block, total shall be equal to 0, because it is being moved slowly. So work done by the spring on the block is nothing but negative sum of the other two. So when we add the other two, okay, we'll get mgh by 2. So here the spring will do minus mgh by 2 amount of work on the block. You can easily understand that. And that comes out to be, because mg is 50 and h by 2 is 0.05. So this comes out to be minus 2.5 joules. And here work done by gravity on the block, which is 2 by 3 into 50, that is 100 by 3 into 0.1. So 10 by 3. So it is easy to understand, okay, both the works done. So please revise this solution once again and try to understand it. Please read this question and then look at my solution. So here the cycle is moving up an inclined plane with the constant speed v. So let me draw a simple inclined plane and the cycle. So this is the inclined plane of inclination theta, and we have a cycle, okay. So you just need to draw the two wheels of the cycle and the chassis, okay. So we know that our pedaling force or torque will be acting only on the rear wheel, and on the front wheel, okay, there will be forces at the axle but no torque at the axle. So if you see rear wheel, for the rear wheel, there is some torque at the axle itself, so which we are providing. Let me call that as tau. And friction has to provide the opposing torque, because the net torque acting on rear wheel shall be 0, because the cycle is moving with a constant speed. So angular speed of the wheels also shall be constant, okay, for them to not to really slip. And accordingly, we can understand that the net torque acting on rear wheel shall be 0. So we can say F into R minus tau equal to 0. Now on the front wheel, also the net torque shall be 0, because that also shall move with constant angular speed and constant angular speed. Now at the axle there is no torque. Now if you think some friction F dash acts here, now torque by F dash shall be 0, okay, because its angular speed is not changing, which makes us realize that F dash is also equal to 0. And therefore if you go to the cycle, you have F, but F dash is 0. So the friction is acting only on the rear wheel, and you have mg sin theta, which is acting down the incline, and normal reaction normal to the incline, actually, which acts on both the wheels. I have not drawn in these three-word diagrams. Okay, I'm sorry. The net normal reaction on the cycle, let us say it is n, and mg cos theta. So clearly we realize that F is equal to mg sin theta, okay, where F is friction acting on the rear wheel, that shall be equal to the component of gravity, so that the cycle does not accelerate. And therefore, now the power delivered to the rear wheel of the vehicle, if each of the wheels have radius r, okay. So what is this power delivered? So the torque we are providing into omega is nothing but the power we deliver to the rear wheel. Now torque is also the torque due to friction, which is mg sin theta into r and into omega. But again, r omega is nothing but speed v. Accordingly, we realize that mgv sin theta is the power delivered. Now, the alternate way of doing this is gravity, which is the only retarding force here, or basically force that tries to retard the cycle, is acting opposite to velocity. So gravity provides a negative power of mg sin theta into v with a minus sign. So minus mgv sin theta is power by gravity. The same amount of power the cyclist has to deliver to the cycle. And whatever power the cyclist delivers, he delivers it only to the rear wheel. He does not deliver anything to the front wheel. Okay. None of his power is even transmitted, okay, to the front wheel, because as such, front wheel is moving with constant speed and constant angular velocity, and except for the axial forces, the normal force and all, there won't be any friction acting on the front wheel in this case. Okay, so the power we deliver to the rear wheel is mgv sin theta. Please read through this question carefully, and then we will discuss. So here we have two pistons, and the middle piston, okay, is immovable. So this is fixed. So the right side gas undergoes isochoric process or constant volume process, and the left side piston has P0 into its area acting, okay, and F also acting from the left side. And from the right side, the pressure of the gas into area will act. And since we are moving it slowly, the force F is moving the thing slowly, it means that the piston is always in equilibrium. And therefore, you can easily understand that the pressure P in the left part of this chamber is constant. And therefore, the left chamber undergoes isobaric process. So one chamber undergoes isochoric process, the other chamber undergoes isobaric process. And we are increasing the temperature by delta T. Okay. And one more thing is, we are not supplying any heat because all the walls except for the middle wall are adiabatic. So if the temperature here rises by delta T, even here also it rises by delta T, because the middle piston is perfectly conductive. That's why. And therefore, we can understand that both the chambers have increased their temperatures by delta T. Okay. Now, let us consider the right chamber. So the heat it receives delta Q R is equal to NCV delta T. Sorry, NCV delta T. And we are told that the right chamber has N2 moles of diatomic gas. And therefore, this is N2, and CV for that is 5 by 2 R into delta T. So the right chamber has received 5 by 2 N2 R delta T amount of heat from the left chamber only, because it cannot receive from anywhere else. So left chamber has indeed delivered that much of heat. So for the left chamber alone, we can write minus 5 by 2 NR delta T, N2R delta T, because this much heat it has lost. That is equal to the change in internal energy of the left side gas is N1 CV delta T plus delta W. And all the delta W that the gas has received is from F. And you can also think that P0 has some share in it. Okay, but let us neglect this atmospheric pressure in this particular case, okay, because we are not given that. So delta W for the left side gas comes out to be minus 5 by 2 N2 R delta T minus N1 into, since that is a monoatomic gas, this will be 3 by 2 R delta T. And therefore, the total work done by the force F comes out to be minus 5 N2 plus 3 N1 minus of that divided by 2 times R delta T. So that is all that is there. Okay. So the work done by force during this time is this much. So please analyze it once again. Okay. And we can move. So guys, please read through the problem and then look at my solution. So here it is clear that magnetic field B bar is uniform and velocity V bar is neither parallel nor perpendicular to it. And therefore, the only path possible in such case is helical path. the angular speed in that helical path, we know it is qb by m. In this case, the charge is 1 coulomb. The magnetic field has a magnitude of 5 root 2 and mass is also given to be 5 root 2. So the angular speed is 1 radian per second. And now the time period in such case will be 2 pi by omega, which is 2 pi seconds. And therefore, the given time interval of 2 pi seconds correspond to one full rotation in the helical path. And we know that in such case, the charged particle will move parallel to the magnetic field, because in one rotation, the displacement of charged particle in a helical path is parallel to the helical axis. And when helical path is in a uniform magnetic field, the axis of the helix is parallel to the magnetic field. So what we know here is that the charged particle moves parallel to the magnetic field. So for its displacement, all we need to do is find V parallel and multiply with the time. Now, how do we find V parallel? It is easy. The V parallel is nothing but V bar dot V cap times V cap, which is very easy to understand. So V bar is 3i cap plus 4j cap plus 5k cap dot B cap means simply B bar by B, which is again 5i cap plus 4j cap plus 3k cap divided by its magnitude, which is 5 root 2 times B cap, which is again the same vector 3i cap plus 4j cap plus 3k cap divided by 5 root 2 into the time, which is 2 pi. So now we can easily get this. So what we have here is 15 plus 16, which is 31 plus 15 again. So 46. 46 divided by 5 root 2 times 5 root 2 will give us 50 into 2 pi times 5i cap plus 4j cap plus 3k cap. And once we get this displacement, that will be nothing but the position, because initially the charged particle is at origin. And this is how you can find the final. Try to understand this question. Don't mind the diagram. Read the question properly, and then you try to understand my solution. So here there is a long cylinder, and current is flowing along its axis. So this is the current, and such a current will cause magnetic field lines which are circular around it, but the magnetic field inside the cylinder will be 0. Now the magnetic field which is outside is changing with time, and so it does cause induced electric field. So in order to calculate the induced electric field, here what I have considered is a loop ABCD on which I am going to use Faraday's laws. A loop ABCD on which I am going to use Faraday's laws. And my claim is that along AB, anywhere there won't be any field, electric field. And along CD also there won't be any electric field. Along AD, there won't be any electric field, because inside the long cylinder, the magnetic field is always zero, so it is not changing with time. So there is no reason why there should be electric field along AB. The only induced electric field will be along BC. Okay, so let the width of BC be X, and this distance is C because we need the electric field, the induced electric field at a distance C from the axis, and that is why we are doing this. Now, we know that at any distance r from the axis of this cylinder, the magnetic field will be mu naught I by 2 pi r. And here, let me consider a small dr. So the area of such strip is x into dr. Magnetic field is mu naught I by 2 pi r times x dr gives me the flux. So when I integrate that, the total flux comes out to be mu naught I x by 2 pi ln C by A, because there won't be any field inside and the radius of the cylinder is given as A. Now, minus d phi by dt gives me the EMF, and that EMF is nothing but minus mu naught x by 2 pi ln C by A into d by dt of dt. And therefore, EMF divided by x is equal to minus mu naught by 2 pi into d times ln C by A. Now I have done EMF divided by x because the EMF will be only along DC, and the induced electric field is nothing but EMF divided by x. So this is the induced electric field at a distance C from the axis. The reason why there should not be any induced electric field along AB or CD, this one I will explain in the next video, because I want you guys to think why there shall be no induced field along AB or along CD. Okay, thank you so much, guys.